green belts for the phase 3 of our black belt journey, the last weekend for our black belt journey. So day 4, we learned certain modules, contents. So I'm going to just recall it for you. And then I will take you through an important concept today, hypothesis testing, right? Which is the heart of the analysis process in any project, right? I'm going to only lay the foundation so that you can comfortably learn the various types of hypothesis testing from Dr. RK, right? So therefore, we talked about process capability. Hope all of you remember. We talked about 2 different indices. One is process capability indices. Other one is process performance indices. The process capability indices are denoted as CP, CPK, isn't it? CP, CPK. And then the process performance indices are denoted as PP, PPK. So we have 2 set of matrices. One is CP, CPK. Other one is PP, PPK. So CP, CPK will reflect your capability. PP, PPK will reflect your performance. Which is most important in the business? Capability or performance? Performance. Right? So we should not forget to or fail to keep an eye on the PP, PPK. Many of the business restrict their thinking only to CP, CPK because that has been talked very widely. Customer demands for CP, CPK, the manager demands for CP, CPK, everybody wants it. But the reality lies in PP, PPK. So it's very important. As a black belt, we keep an eye on the PP, PPK to make very effective decision. Otherwise, what happens? You may think that you are able to convince your customer, you are able to convince your boss and everyone, but still in real time, the results may not fall in place. So the realistic measure of your performance is PP, PPK. And also, whether you are measuring CP, CPK or PP, PPK, what is most important is your process should be under statistical control. If you plot a control chart of your process characteristics, all the points should be inside the control limit. Then only it is advisable and permissible to conduct a capability study, calculate CP, CPK and PP, PPK. If the control chart itself is not under control, if the process itself is not under statistical control, and doing a capability study may not give the real picture. So generally it is not advisable, not permissible, right? But however, if the situation demands, somebody is wanting you to give the CP, CPK, then to get the CP, CPK value, you can exclude the outliers in your data. You can exclude the outliers in your data and calculate CP, CPK. But now it is very important to understand that the calculated CP, CPK is a measure of your capability provided the outliers are excluded. Why there are outliers? Because there are no special causes. Your points are going out of the control limit because your process is get disturbed. Either the variations are going high, or the process central tendency is shifting, and that is why points are going beyond the control limit. So you need to fix these special causes. So you must understand, you must recognize the need for improvement of the process when you see points falling outside the control limit. Under such situation, it is not a good idea to measure the capability, but still you may have to measure it because the business wants it, right? You only know that it is not advisable to measure the capability under such situation, but still, since the business wants it, you measure it by excluding the outliers. But what is required? Outliers should not appear. For that, you need to run projects. What are those projects? Process improvement projects. So presence of an outlier, presence of points going beyond control limit will help you to recognize the need for process improvement. So keep that in mind. Subject to that condition, you can calculate CP, CPK. But still wiser decision is looking at the PP, PPK. If you are really performing your job as a black belt very well, monitor the process properly, and you are able to ensure the stability in the process. That means all the points are within the control limit, and the within variation, between variation, everything you are able to control it, in your fingertip. Under such situation, you will see your CP/CPK as well as PP/PPK approaching each other. That's the moment you can realize, you are really able to, control the process very effectively, because you are going to be successful not only in short term, but also in long term, right? So this is how you need to, play with the CP/CPK as well as PP/PPK. And of course, the formulas and all, you can always refer to the slides, and then many literatures are available. And CP/CPK, PP/PPK. One more clarity. Take the CP as well as PP. You know the difference between C and CP/CPK and PP/PPK. But CP and PP, there is a similarity. CP and PP, there is a similarity. What is the similarity? Both of them, monitors and measures the degree of variation. Both of them monitors and measures the degree of variation. If the degree of variation is too high, your CP will go down. Your PP will also go down, right? And similarly, CP/CPK and PP/PPK. CPK and PPK, both of them are measure of not only variation, but also central tendency. CPK and PPK are, both of them are measure of variation as well as central tendency in the process. And that is why, they give more clear picture than your CP and PP, right? And because your process can produce defects, either due to the very high degree of variation or shifting of the central tendency. So it's important you monitor both, and this is what we learned in CP/CPK and then PP/PPK. It was very clear to all of you, right? Which one is the best measure and which one we need to calculate and how to calculate, and the situation where you can actually proceed with capability study. You can proceed with the capability study only if your process is stable. If the students in your classroom are really willing to listen to you, then you conduct the sessions. This is what we are also telling. Conduct the capability study only when your process is ready for it. That readiness is understood using a control chart, which you will be learning in the control phase. Hope it is clear. Shall we move on? Right. And then we also discussed about yield metrics. The three types of yield we discussed: traditional yield, first pass yield, and throughput yield. And the traditional yield considers only the rejections. Only the rejections are considered, and the rework is not considered as a failure. If you consider the rejections as failure, then the type of yield you are calculating is traditional yield. If you consider rework also as a failure, then the calculated yield is called what? First pass yield. And then what is throughput yield? The overall performance. Ultimately, the overall performance matters, isn't it? Finally, what is the end? That end should be in our mind, right? And Stephen Covey also highlighted this concept in his book on 7 habits of highly effective people. Begin with an end in mind. So what is going to happen in the end? Individually, processes are doing good. Individually, people are good, but collectively, nothing, right? So that is what we are trying to measure in rolled throughput yield. Starting from the raw material till the final product, there are various stages, various process. Every stage, every process will have its own yield. But what is going to be the overall yield? So what is important is throughput yield. Throughput yield is simply multiplication of all the first pass yield at all stages, right? This also be understood. And then the other day you also learned about the DPMO, defects per million opportunities. You did a GEMS experiment, and that is also a measure of baseline performance or measure of capability. And PPM, parts per million, right? So, and in my opinion, monitoring defects is better than monitoring defectives, right? So parts per million is a measure of defectives. DPMO is a measure of defects, right? Every opportunity for a failure is considered a defect. Every product that is getting rejected is considered a defective, which is most important. Accordingly, you can choose. And then also the sigma level is at ST and is at LD. Sigma level, again, it's a measure of capability. So higher the sigma level, higher will be the capability. Sigma level is different, sigma is different. Sigma is simply standard deviation. We want less of it. But sigma level is measure of capability. We want more of it, right? When you want a higher capability, then see to that your sigma is low. And also within the sigma level, there are two types: short-term sigma level, long-term sigma level. Short-term capability, long-term capability. So there are two metrics exist. One is ZST, other one is ZLT. Always ZST will be higher than ZLT because over long run performances are expected to deteriorate. And so long-term capability will be always lower than short-term capability. So the relationship between ZST and ZLT is statistically predicted as ZST is always equal to ZLT plus 1.5. ZST is always 1.5 units higher than ZLT, right? Or in other words, ZLT will be equal to ZST minus 1.5. So this is what we learned in measuring the baseline performance. All of you are clear with it? Whether you are using sigma level, you are using DPMO PPM, or you are using yield metric, or you are using CPCPK, or you are using PPPPK. There are 5 different variants we have studied. Why? To understand how are our team performing. So how is our process performing? So we call it baseline performance. To get a realistic measure of the baseline performance, 5 different metrics are available. Whichever best suits according to your product, according to your service, right? According to the practice in your organization, you can use it. All of them are, in my opinion, all of them are almost gives the same interpretation. Now, and then in the afternoon, you discussed about analyze phase, right? In analyze phase, what is your goal in the analyze phase? You wanted to identify the root cause of the problem. You wanted to validate the root cause of the problem, isn't it? So you want to identify as well as validate the root cause. If you want the root cause, you must know what are the causes first. You must know what are the causes. So how do you list the possible causes? What are the tools you learned? You learned brainstorming, you learned Y-by analysis, you learned the cause and effect diagram, right? So these tools will help you to identify the possible causes. You need to differentiate between a few terminology. Possible causes, potential causes, and critical causes. What is the difference? Possible causes, potential causes, and critical causes. A problem has happened and something has gone wrong. Why your results have gone wrong? Because there are certain factors which have influenced your why, right? The possibilities, with the possibilities exist with all the factors. We really don't have any idea as of now, isn't it? So the first step you need to do is you must list all possible causes. It is something like a crime has happened, and who is the culprit? The possibility is whoever there in the situation, anyone, one out of the crowd is going to be the culprit. So it is very important to list down all those who are present in the situation. Similarly, all those X factors that are present in your process. What are X factor? The input and the process parameter. Those are called possible causes. It is only to list down all the possible causes. We use tools like brainstorming, tools like cause and effect diagram, and tools like Y-by analysis. You can always combine the three. To effectively list down all the causes. And then I wanted to understand the potential causes. How do I understand the potential causes? So what's the difference between a potential cause and a possible cause? It is most likely that that particular factor is the culprit. But your thinking is more subjective. That is why you use the word potential causes. You may or may not have evidence, right? You call it potential causes if the statement is purely based on the opinions. So you call it potential causes. It is for that purpose you learned a tool called cause and effect matrix. What is the tool you learned? Cause and effect matrix, right? You place the factors into 4 quadrants: the high impact, high control, low impact, low control, and things like that, right? And finally, the high impact, high control, the factors that fall, can be considered as potential. Similarly, there will be one more quadrant with the high impact. So that can also be considered potential causes, because the factor has higher impact, and hopefully that could be one of the culprit or one of the cause. So either you can use cause and effect matrix, and after using, or you can also use like the tool similar to prioritization matrix, like what you learned the tool in prioritization matrix. Using certain criteria, you can assign certain number, and then you can rank the causes. Once you have the weighted rank, plot a Pareto. Pareto will show you the potential causes. Whatever causes that appear in the front, the first few bars will reflect the potential causes. So now you are able to move from possible to potential. But potential, when I say, the word is subjective. I want to be very specific. I want to quantify the impact. So I will move on to the next stage, where I will measure the criticality. In order to measure the criticality of the factor, in order to call a factor as a critical factor, I will use a quantitative technique called hypothesis testing, and that is what I'm going to teach all of you today, right? So the criticality of the factor can be understood by doing some testing. It's a statistical procedure. We'll quantify the criticality, and if the quantum of influence is found to be significant, then we consider the factor as critical factor, and then we will consider that as the root cause, right? But still you may, if you are not convinced, then you need to go one step further. What is one step further beyond hypothesis testing? Design of experiments. That also we are going to discuss tomorrow, right? So this is how you move from possible causes to potential cause to critical cause to root cause. Most of the organizations solve the problem simply at the first stage, at the possible cause. So they will not be able to solve all the problem. Maybe to a certain extent they will be successful. But the organization that can move to the extent of potential causes can solve problems very efficiently. And but the organization which can travel up to critical causes can definitely solve 95% of the problem. But still, the last 5% of the problems might deserve the tool called design of experiments, right? So it's important, as a black belt, you master all these things. So this is what, in essence, we studied on the tools we studied on day number 4. If there are any questions, I will be happy to answer. Otherwise, we can move on with today's agenda. Just 1 minute.